Related to the previous question, in one with a graph there, we solve analytically why all the solutions of that equation 4 cos x and 2 lie between x equals minus 2 and x equals minus 6. Comes back to the idea that we know cos of x has to be between minus 1 and minus 4. So if that's the case, if we get cos of x must be between minus 1 and minus 4, we can simplify our function to get cos x equal to 2 minus x on 4. If that's got to lie between minus 1 and minus 4 and minus 1 and 1, that's got to lie between minus 1 and 1. So let's solve it. So multiply both sides by 4. Subtract both sides, 2 off both sides, so it gives us the minus 4, and that gives us 8 from the minus 4 goes to minus 6, and 4 goes to 2. Then minus x, if we multiply that by negative, we multiply negative 1, all the others get multiplied by negative 1, and so the signs will change as well. So as we get x is greater than minus 2, and x is going to be less than 6. So we've solved cos of x basically between minus 1 and 1, and then so the other function that must be equal to cos x gets solved between minus 1 and 1. So drawing the graph here, the number of roots, remember roots is where the values of x would be the same. So where do these two intersect? So if we draw up sine of 2x, remember that's going to increase its period. And half x, what does that look like? Now again, we've got to be in radians because we can see that a half of x, so where would be 1 there? The 0.21, so it's a little bit less than 2.3. That's the 0.21 there. So where would be at a half? So there'd be at 1 there, so which is a little bit less than 0.3. So we're not really looking for solutions, but how many places do they intersect? How many roots do we get? We get 1, we get 2, and we get 3. And we're not going to get any more because the curve keeps increasing that way. That one keeps oscillating in both directions. Question 4 here. Just draw up cos x and y is equal to x. So that we can see again. So at 1 there, it's at 1 there. So 2, 2, 3, 3. We will draw up that curve. This the line, and the curve cos x. We know what that one looks like. How many roots do we have? It only intersects at one spot. So it allows us to find the number of roots. We're not really caring what the root is, but how many roots does those two graphs intersecting have.